reduced row echelon form. That's the abbreviation RREF here. So we did the 1 in the top left corner, moved on to the 0, came across, made that a 1, finally went up and made that a 0. And once we did that, we very clearly saw what x and y were equal to. So the homework answers that I just showed you actually had the matrices in this form, REF, which is just row echelon form. The reduced row would actually, the only difference is that we make that 0 up there. And you'll notice in the row echelon form, that's actually just any old number. So what I'm going to show you today is how maybe you can shortcut some of those steps, which, by the way, the steps in this process are called row operations. Okay, we're doing, some operations on the rows in the matrix here, and that's how we're coming up with these answers, right? So I'm going to show you maybe how we can shortcut some of those row operations by maybe just getting the matrix into row echelon form. All right, so this example right here says 8x plus 3y equals 2, 5x minus 6y equals 17. So if I write the augmented matrix, first row would be 8, 3, 2. Second row is 5, negative 6, and 17. And the first thing I still have to do, even though we're going to try and get this to be our goal today, REF, is make that a 1. So to make that a 1, I'm going to take row 1 and multiply it by 1/8, and that will be my new row 1. This is the work that you're doing, by the way. I would like you to write what's happening off to the side, because if we're looking at your work and your matrices were just, a bunch of numbers everywhere, I wouldn't necessarily know what your goal is if you, make a mistake somewhere. So we get 1, 3/8, and at the end you get 2/8, and if you want to write 2/8 as the reduced 1/4, not a big deal there. 5, negative 6, and 17 is the bottom row. You're still going to proceed in the same order. So the next thing you have to do is make that 5 into a 0. Now that this is a 1, that's pretty easy for us to do. Take negative 5 times row 1, add it to row 2, and all of that's going to be the new row 2. So go ahead and recopy row 1. And my new row 2 has a 0 in that spot. That was the whole goal. Negative 5 times 3 is negative 15/8. And, oh boy, let's see, minus 6. So that would be negative 48/8. So 15 and 48, I believe, should be negative 63/8. I'm hoping I'm not going to regret not having a calculator next to me right now, but we'll give it a shot. All right, negative 5 times 1/4 is negative 5/4. Plus 17. 17 is really 68/4. So negative 5 plus 68 is positive 63/4. And I'm certainly not expecting that you're doing all these operations in your head. You can go back and double check some of the stuff on calculators, but I believe we're actually in a pretty good place. The only thing we actually have one more step. If you look at our goal for today, which is REF, row echelon form, just make that into a 1, and we know we can make a 1 by multiplying by the reciprocal here. So we're going to take row 2, multiply it by negative 8 over 63, and put that into row 2. It seems like a tricky step to multiply by that reciprocal there. Okay. But what's going to wind up happening is when I multiply the 63/4 by negative 8 over 63, notice how the 63's cancel top bottom. So we're left with negative 8 over 4, which is negative 2. Okay. So therefore, we wind up getting that the solution, we definitely know at this stage that y equals negative 2. And if y equals negative 2, how am I going to use that information to go find x? Because x is not 1/4, like it was in reduced row echelon form. So what we're going to do is we're going to take that top row and just transfer it back into an equation. So look at this top row here. It would be x plus 3/8 y equals 1/4. And if I just transfer that back into an equation, plug in your value of y. Okay, so that would be y is negative 2. And then solve for x from there. So you can go ahead and reduce this a little bit, right? 2 would go into 8 4 times. So you get x minus 3/4 is what that would be, equals 1/4. And if you add 3/4 to the other side, 1/4 plus 3/4 is a total of 4/4, better known as 1. So the solution to the system would be 1, -2. And I'll tell you, even though I actually went to the equation from the matrix here, I guess you actually could even go back to one of the original equations, take your value of y, which is -2, and plug it back in to find the value of x. Not a huge deal, okay? But that row echelon form does take one more step out of the process that, you know, if I can find y, I think you guys can probably back substitute pretty quickly there to find the value of x in this case. So the reason why I wanted to show you that is two things. One, the homework answers that you saw me post at the beginning of today's video. Well, this is the format that I solved those in. So I didn't go all the way to reduced row echelon form. The other reason I want to show you this is that today that will be our focus when we solve 3x3 systems. So I'll show you what I mean when we write down the first example here. All right, so if I can find the first example, that would be good. All right, in our 3x3 systems today, I'll write down the first example, and then I'll show you what the goal looks like and what row echelon form looks like for a 3x3 system. So the equation starts off with, we're going to have 3 equations, 3 unknowns, x minus 3y minus 2z equals -3. Next row, 3x plus 2y minus z equals 12. And finally, last equation, -x minus y plus 4z equals 3. Okay. You actually solved equations like this in Algebra 2 last year, and you probably took a different approach. You definitely did not learn this using matrices, whether you're in Algebra 2 Regents, Algebra 2 Honors. You probably did a whole system of eliminating pairs of variables and kind of going from there. I kind of think matrices is a nice way to organize our information, and it's extremely useful, especially once I show you how to do it on the calculator. Okay. I'm going to write down right now what the goal will be. So the goal of this whole process is to get this into row echelon form. So if I create a matrix, now we're going to have a 3x4 matrix, 3 rows, 4 columns of numbers from the equation. What we want is we want ones going down on what I call the main diagonal. Okay, the main diagonal is the diagonal that goes down from left to right. Underneath those ones, we want a series of zeros. Okay. Above the ones, you can have any old numbers. Doesn't matter what numbers are there, because when we get to this point in the process, as long as this last bottom row says 0, 0, 1, there's going to be numbers on the other side of the wall. And what I'm going to know at this last step of the process is that z equals this number. And if z equals this number, I can come up to the second equation and substitute it into an equation that only has y's and z's in it. Then I'll find y. And finally, I'll go back up to the top and find x. So that's what the process will look like. Find z, back substitute to find y, and then finally substitute one more time to find x. The good news is that the way we make ones and zeros is the same way that we made ones and zeros for a 2x2 system. Okay. I tend to do this. I don't think all teachers do this. So if you're following along with, Mr. Kakainen or Miss Crowfoot for some reason, I like to draw a little staircase in that the ones sit on top of. So what I tell my students all the time is make a 1 on the step and make zeros underneath the staircase. Just a good reference point here. And actually where we're going to start, maybe this won't be too much of a surprise, top left corner, we're going to make that a 1. Then I make zeros underneath that step. Once those are both zeros, then I come over to the second step, make that a 1. Put a 0 underneath it. This is the last part of the process, making this value a 1. As soon as that's a 1, then I actually am pretty close to solving the system. Let's see if we can make this happen for this example. So create a 3x4 matrix with these coefficients. So we've got 1, -3, -2. Draw the wall to separate the answer there, -3. We've got 3, 2, -1, and 12. -1, -1, 4, and 3. Okay, with this augmented matrix, first and foremost, we want to make a 1 in that top left corner. Good news, it's already a 1. I'm going to draw that staircase in that I just referenced a second ago. If your top step already has a 1 on it, good news. If it doesn't have a 1, consider looking to see if it can be switched with a row below it, because we can still switch rows, or we would just multiply by the reciprocal of what's there. All right, next thing I'm going to do is I'm going to make that 3 into a 0. So we should be pretty good at making zeros. I'm going to go to the top row, multiply that row by -3, and add it to row 2. It's going to be especially important now to keep track of, now that we have 3 rows, which row is changing and which rows are staying the same. So row 1 is not changing in this process. You can recopy that. Row 3 will not change. If you want to recopy that at this point, go for it. And let's see what the new row 2 is. So we're going to do -3 times that top row and then add it to the second row. So it's not going to be a surprise that that becomes a 0 in the first spot of row 2. -3 times -3 is 9, plus the 2 is 11. -3 times -2 is 6, plus -1 is 5. -3 times -3 is 9, and 9 plus 12 is 21. And this is all. I hope you're listening over there, because if I don't know, I'm just saying, if I make a quick addition mistake, not that you'd be good at helping me with that anyway, but if I make a multiplication or an addition mistake, I need you to chime in.
I can get you a calculator.
No, she can get me a calculator. That's good, guys. So the heartbreak of all this is not that the process will be that challenging for you eventually once you get more practice. It's that sometimes you make one addition mistake and then the whole thing's thrown off. Or sometimes you forget to carry down one negative sign from one row to the next. Or the really unfortunate thing is that sometimes I see students who don't copy the matrix over correctly from the very start. It's like, oh boy, then we really have to start all over again. So I'm going to try and go slowly, at least through this first example, make sure that these values make sense, but definitely something to look out for as you're going through the process as well. This is all apparently is not going to listen or be of help to us here. So, but she'll get us a calculator if we need it. Okay. So there's my staircase again. We've got a 1 on the top step. Next thing I'm going to do is, just like I explained earlier in the general form up here, once you got that 1 on the top, make zeros underneath that step. So now I want this to be a 0. To make that into a 0, still got to think about adding rows together. The nice thing is that there are already 1s there, right? So this operation will just say, take row 1 and add it to row 3. And then that will be the new row 3. Right? We don't even have to multiply row 1 by a constant. We're just going to add the rows together and put the results in row 3. So row 1's not changing. Row 2 is not changing in this step, but the new row 3 will have a 0 there. That's good news. Add these, -3 plus -1, that's now -4 in this spot. -2 plus 4 is +2. -3 plus 3 is 0. Don't panic too much if that's a 0 on the right side of the wall. Not a big deal. It actually will probably change at some point anyway. But yeah, if you get zeros on this side, definitely not a big deal. You can have a, the original equation could have been equal to 0. So let me go and draw the staircase back in. So now we're actually up to the next step in the process. Literally the next step. So the next step in the middle here, that's an 11. And what do I want that to be? Well, I want it to be a 1. We're pretty good at making 1s. To make a 1, you're going to take that row and multiply it by the reciprocal. So I'm going to take row 2, multiply it by 1/11. That will be the new row 2. So recopy the system. Row 2 is now 0, 1. All right, so now we got some fractions in the mix. Not a huge deal. 5/11 and then 21/11 is what we got at the end there. And then 0, -4, 2 zeros, that bottom row. Okay. Draw the staircase in. We've now got a 1 on that second step. And I want to make a 0 below it. Okay. This is kind of an important part of the process because everything else I would hope until this point seems pretty familiar and similar to what we did yesterday. But I'm going to try and make a big deal of, to make this a 0, I want to multiply not row 1 by something, but row 2. Because first of all, there's a 1 above it, so that's going to be a lot easier for me to figure out what should I want this number to be, such that when I add it to -4, those things are going to cancel, right? I can really easily multiply row 2 by +4, so actually that's the operation I want you guys to write. I'm going to do 4 times row 2, add it to row 3. That's going to make a 0 there. But the other reason why you definitely don't want to use row 1 in this case is if you go up to row 1 and you multiply it by something and add it to row 3, it's going to change this so it's not a 0 anymore. It's going to undo the work that we did to make that a 0. So make sure in this stage, when you make a 0 underneath that second step, go up to row 2, and that will be the easiest row to use anyway. So that's good news. Okay, so recopy row 1, nothing's happening there. And then row 2 is not changing this process. We get 0, 1, 5/11ths, and 21/11ths. And then we got to do 4 times row 2, and then add it to row 3. So this is still going to stay 0, right? 4 times 0 is 0, plus 0. That's good. I didn't want that to change. 4 times 1 is 4, plus -4, 0. Perfect. All right, now we got to work with the fractions, though. 4 times 5 is 20/11ths. The number 2 would be the same thing as 22/11ths. So 20 plus 22 would be 42/11ths there. And then at the end, 4 times 21, that would be 84/11ths. Luckily, I have to add that to 0, so that's just 84/11ths. Okay, we've really got one more step to go here, guys. We're almost done. And on that last bottom step, I want that to be a 1. All right, how do we make a 1? Multiply by the reciprocal. So I'm going to multiply that entire row by 11/42, which seems scary, but I promise it's not. Watch what happens. Okay. So the only thing that's changing right now is going to be row 3. And in row 3, we're going to get 0, 0, 1. Finally, we got to the step where we're in row echelon form. But the last thing I have to figure out is what is 84/11ths times 11/42. And like we've seen in some other examples, those 11s cancel. And 84 divided by 42 is nice. It's 2. So how do I take this system right here and figure out the values for x, y, and z? Well, first and foremost, that last section at the very bottom, remember the first column, these are all the x coefficients, the y's, these are the z values. That last equation says z equals 2. I'm sorry, timer going off here, guys. Time is up. Sorry, actually, z equals 2 is as far as we're going to get. It's been nice hanging with you guys here today. All right. So we've got z equals 2. And now I'm going to go up to the second equation, and I'm going to use that to find y. You got to go to the second equation next, because that second equation has no x's in it, which is good. So what does that second equation say? It says y plus 5/11ths z equals 21/11ths. So go ahead and plug in your value of z, which is 2. So if I plug in a 2 here, 2 times 5 would make that a 10/11ths up there. And if I subtract 10/11ths to this side, 21 minus 10 would be 11/11ths, better known as 1. Okay, so even though we had some fractions, like we've seen in other cases, these actually are coming out to be nice answers. Finally, go up to the top row, and those are all nice integer coefficients up there. You get x minus 3y minus 2z equals -3. Plug in your values for y and z. Y is 1. Z is 2. So if you have -3 minus 4, that's a total of -7 on this side. Add the 7 over to get x equals 4. So we've got a value of x, a value of y, and a value of z. And the last thing I'll say about this is that we would write our solution as 4, 1, 2. Just write it in the order of x, y, z. So we're pretty used to writing an x-y pair, but it wouldn't be too hard for us to then extend this out one value further and write it in the order x, y, z. Okay. know it's an intense process. Hopefully you guys are getting pretty good at stopping along the way and really taking the time to write down the matrix carefully each time. I'm going to do one more with you, and then I'll give you some homework to think about for more practice here. All right. All right. You're going to like this one. This one, I think, is maybe even a little bit nicer than the first one. We started with the hard one today, which is good. Okay. So the last one, I'm hoping you're in an okay place that maybe I don't even have to write the equations down. So I'm actually going to cheat a little bit and just write down what the augmented matrix would look like to start. So we got 1, -1, 3, 5 for the top row. Second row, 3, 2, -2, 4. Last row, 4, -3, 1, 9. Okay, so what would that top row have said in an equation form? It would have said x minus y plus 3z equals 5. So I just transferred that right over to the augmented matrix, and we're going to go from here. Okay, first thing I'm going to do is make that top step a 1. Well, luckily it is. It may not always be that way. Totally fine. Think about switching rows. That's the easiest way to do it. But if there's no 1s below it, well, then you're going to have to multiply by that reciprocal. Let's make that 3 into a 0. Next step, -3 row 1 plus row 2. And that becomes the new row 2. Now that you've seen one example, I might move a little bit faster through this one. All right, recopy row 1. I also know that row 3 is not going to change. So we get a 0 there. That's what I wanted. -3 times -1 is 3, plus 2 is 5. -3 times 3 is -9, plus -2 is -11. And then here you're going to get -15 plus 4, which is also -11. Okay, so we made a 0 in that spot successfully. Draw the staircase back in. Now I want that 4 to be a 0. To make that 4 a 0, take row 1, multiply by -4, and add it down to row 3. And that's the new row 3. Okay, so go ahead and recopy row 1. Row 2 is not going to change. So then we get 0 in the spot, which is good. -4 times -1 is 4, plus -3 is 1. -4 times 3, -12, plus 1 is -11. -4 times 5 is -20. -20 plus 9 is, boy, we really love the number -11 in this system. It's hanging out all at the end there, isn't it? Okay, draw the staircase back in. Now that you made the zeros underneath, go to the second step. Where that 5 is, I want it to be a 1. There are 2 ways to make a 1. One way would be multiply row 2 by a 5th. And I have no problem or issues with you doing that. But is anyone seeing that? Look at this. Right below it, there's a 1 sitting there. And the hard work that I just did to make those zeros, would switching row 2 and row 3 change the fact that these are both zeros? Not in the slightest bit. So the easiest thing to do is this. Switch row 2 and row 3. If you multiply by a 5th, you would still get the same answers in the end. So I don't want to discourage you from using that process. But when you notice things like this, it does make the process much easier. So now we got 0, 1, -11, -11. And actually, you know, the ends there. Kind of weird that we have all those -11s. Okay. All right, now that I've gotten a 1 on that step, the next thing I want us to do is make that 5 into a 0. All right, to make that into a 0, remember you're going to row 2. Don't go up to row 1 and try anything there. Okay, because if I go up to row 1, even if you're like, hey, Mr. All, multiply that by 5 and add it to this, isn't that 0? Yes, but it changes this, so it's no longer 0. And we don't want to do that. So go up to row 2, multiply that by -5. Add it to row 3, and that will become the new row 3. Okay, so row 1 not changing. Row 1 doesn't really change a lot, other than maybe having to make this a 1. It's really not going to change much at all. All right, row 2 is not changing in this step. And row 3 is now 0, 0. Okay. -5 times -11 is 55. Plus -11 below it is 44. And then the same thing happens at the end, because luckily those are actually the same numbers, right? So that's going to be a 44. All right, one more step to go. And I'm hoping you're saying, hey, to make that into a 1, you're going to take row 3 and multiply by the reciprocal 1 over 44. And that's the new row 3. And I'm thinking we probably already knew anyway without doing this, but just for the formality of it all, I'll write down what we would have there. It's going to be 0, 0, and then 1, 1, right? So you probably already knew based on this last equation that z would equal 1. But now you can clearly see when I multiply that and I get it into this beautiful row echelon form that that last equation would say that z equals 1. Okay. Start back substituting to find the values of y and then x. So the second equation right here says that 0x's, right? So y minus 11z equals -11. So if z is 1, that would be y minus 11 equals -11. Add the 11 over, y equals 0. Not a big deal. Y can equal 0. All right, and then finally go back and find x. That top equation is x minus y plus 3z equals 5. Okay, y is 0, z is 1. So this is going to become a total of x plus 3 is equal to 5, and then you get x equals 2. So all in all, your solution is 2, 0, 1. Really nice here because we didn't have any fractions to contend with. Not that fractions should be our enemies in this process.